My years of lecturing experience clicking straight in there. Okay, right, so let's keep track of the time. Yeah, okay, so I'm Chris Welch. I will be your conductor tonight on a little journey through something I've called black sky thinking. It's not an original phrase of mine. I think the first time I saw it used was by a Demos report back in about, I think it was about 2006, 2007, when they were looking at kind of UK space policy and blue sky thinking, black sky thinking, and I've always kind of rather liked that. Most of this talk is to do with two things really, technology and money. Okay, that's the kind of intersection tonight. So we'll start off with space and money, okay, because the question was, can you make money in space? The answer is yes, there's a lot of people already making money in space. This shows you the size of the kind of global space economy. So about $330 billion in 2014 globally. And it went up 10% from the previous year. It's gone up about 50% over the previous 7 years. And one of the things that is fairly clear, if you look at the global space economy, you know, all wrapped in, is it just grows year after year after year. Even when the economy has tanked out, okay, the global space economy just goes on getting bigger. So it's quite a good place to invest money and spend money. And most of this increase is from commercial growth. It's not from governments putting more money into space programs. In general, okay, government budgets have either stayed static or in some cases decreased. So most of this growth is in commerce. It's interesting to note the effect of the US, though, which spends about half of the global government money in space that we know about. That's the programs we do know about. Of course, there are undoubtedly programs that we don't know about that they're spending on in the kind of military space domain. So this is commercial civil space that we know about. And you can sort of see a breakdown over here. But if we look at the next slide, this probably puts it a little bit more into perspective. This is kind of satellite service revenues, because this is where most of the money in space is being made. It's being made by building satellites, launching satellites, and then operating satellites to provide services of various sorts for people on Earth, and that's where the money comes from. And you can see, first of all, that it's going up as time goes on, and then you can see that there's different parts of the bar chart here, and actually, although you can see clearly 2 bits, there's actually 4 bits, but 2 of them are big, and 2 of them are relatively small. So the people who make the ground equipment, okay, that's the people here, to talk to the satellites do quite well. The people who actually provide the satellite services do extremely well, okay? And then in the middle here, you get the people who build the satellites and launch the satellites. So although a lot of the focus is on rockets, whoosh, up they go, aren't they spectacular? And there is certainly money to be made out of launch services. The actual serious amount of money gets made in satellite telecommunications. So the people who are making money are SES in Luxembourg, Inmarsat down the road in Old Street, Intelsat, people like that. That's where the money is in contemporary space. But if you like, you know, how much does space cost citizens? This is commercial space. Sometimes I come to lectures and talks like this and people go, well, I still think we're spending too much money on space. You know, that European Space Agency, it gets paid way too much. So just to address that, okay, slightly old data here, but in 2011, Europe spent approximately 4 billion euros on space programs, which is quite a lot of money. If someone was to give me 4 billion euros, I'd be a pretty happy person. Europe's GDP is about 13 trillion, or was then. So in GDP terms, that's, you know, 0.03% of GDP, which is not really very much. Europe's population, call it 740, 750 million. You know, who knows, by Friday it might have gone down by 60 million. Then I'll have to redo the slide. Actually, yeah. It's a little more complicated than that because this includes 2 lots of funding. There's the European Space Agency, which is separate from the European Union, and they both fund space projects, but they're different organizations. The European Space Agency is not the European Union Space Agency, which is why Canada is a member of the European Space Agency, but is not, as you will have noticed, in Europe. And there was even some talk, I gather, about Australia joining ESA. You know, so we will see. So what that means is that space costs us each about 5.5 euros a year. Now, when I came in earlier, they very kindly offered me some food, and I accepted the food. And actually, this burger and fries is worth more than my annual contribution to the European space budget. And I quite like burgers and fries. And I quite like space, and I'd actually spend more money on space than I would on burgers and fries. So collectively, we're not spending very much money on space. That's what it works out to. If you look at other spending, okay, by comparison, 4 billion on space programs, 200 billion on military programs across the European Union. I don't mean European Army. I mean or European. I mean country by country. Or since we're in a pub, okay, spending on alcohol and tobacco. Okay, I've lost the number there, but it's twice that. It's about 400 billion euros, So that's about 500 euros each. So if you're, only spending 200 euros each, as a person on booze and tobacco each year, somebody else is getting your money. You need to up your game and spend more, because it's about 500 euros. If you're spending more than that, perhaps you could consider donating some of it to the space program. So. How much is a lot? In absolute terms, all these numbers, 4 billion is obviously an enormous number, but when you put it into perspective of what we spend on other things as a society, it's really very, very little. Put it into perspective, this is the European Space Agency budget, so just ESA, not the European Union, and you can sort of see here how much they spent in different areas there. So human spaceflight, since we've just got Major Tim back, ESA invested, 400 million euros a year roughly in making that work. Launches, okay, 600. Earth observation, okay, big chunk there, 860. Telecoms, navigation, robotic exploration, science, and so on. So that's that's the budget in actual numbers. If you then look at that per person per year, okay, how much did each of you pay, okay, over recent years, contribute to Major Tim going to the International Space Station? Well, it was about €0.50 per person per year, okay, and that's what it costs Europe to have a human spaceflight program. So when people say, oh, human spaceflight is so expensive, it's kind of 1/15 the cost of my burger. Per year, so not very much. And the same for all these other things. They're big sums of money in total, but in proportion to everything else, they're quite small. Now, the UK, people think, oh, UK doesn't do anything in space. Well, that's not true, really. The UK actually has at the moment, quite a vibrant space economy. One of the last things I worked on before I left the UK and went to work at the International Space University in France 5 years ago was a thing called the Space Innovation and Growth Strategy, which was a sort of combined project of academia and industry, which basically gathered lots of evidence, put it into reports looking at different areas, and then said to the government, look, no matter what you do, the space economy keeps going up. So wouldn't space be a good place to put some government money? And in the way you do, you submit these reports and then sort of walk away going, had another shot. We were very surprised when it turned out they actually listened to us. And they went, oh, golly, you're right. Let's put some more money into space. And we now have this plan. This is the latest version of the Space Innovation and Growth Strategy 2014-2030. Okay, so covering the next 15 years. UK space sector brings in about 9 billion a year to the economy. Directly employs 30,000, and depending on what you consider to be downstream employment, many, many more. You can, depending on how you judge the figures, it could be up to 120,000, and it's got an average growth rate of about 7.5%. So it's a good sector, and the UK, therefore, government space policy is to capture 10% of the global space economy and global space market by 2030. So we have 15 years, as a country, to sort of really tool up and start sort of producing more companies, more people, more experts to do this. And with another hat on, I'm involved with something called workforce development, and quite how we're going to do this, not just in the UK, but across Europe, and in fact, across the kind of the technological world, is actually not clear, because all the statistics show that actually less people are going into the STEM subjects that you would need to support this. But nevertheless, that is the plan. 10% of the global space market. So then, that kind of provides the kind of background. Now to talk about new space, because all that money that's been made in satellite telecommunications and so on, is mostly been through what is called old space, to differentiate it from new space. Old space means big government programs, space agencies, and what is still in some sectors called the military-industrial complex. So this is a... Sorry, yeah. That was them, yes, I was just wondering, and here comes the SWAT team. And so it tends to be requiring large amounts of government money to support government-initiated space projects. And it gets results, but it's rather slow and has now achieved, some people would argue, a kind of monolithic structure. And it needs to be disrupted in the current terms. And so this concept of new space, sometimes called outspace, is that it tends to be private, not involved with the government. It tends to be entrepreneurial, and it tends to focus on low-cost approaches. Now, low cost is a relative term, as you would guess in space, but low cost compared to other things. And so here you can see a CubeSat structure for a small satellite. Here you can see one of SpaceX's rockets. Here you can see the astrobotic lunar rover, Bigelow Aerospace inflatable structure. So I'm going to talk a little bit about the domains in which it's possible for new space activity to happen. And then really I'm going to run through a whole bunch of new space companies and activities just to kind of give you an overview of what they're doing, because there's actually an awful lot going on, far more. I had some tough decisions to make because I left out a whole bunch of slides about particular companies, particular activities that I just thought, unless I'm going to talk for 3 hours, I'm going to have to chop those slides. So if we think about the domains in which we could operate, we could have suborbital, and I will explain the difference between that and orbital in a minute, orbital or deep space. So basically close to Earth, in orbit, or out there in the wild black yonder. So the important thing to understand to start off with is the difference between suborbital and orbital, because space officially starts 100 kilometers up. There's a line, that side, not in space. This side, in space. And that's it. I'm an astronaut. I've gone above 100 kilometers. I get the little pin and everything. And so it's not so much whether you go to space, it's whether you get into orbit. And they're different things. You can imagine that if I threw something up, hard enough, it would just go up, 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 up. And if I threw it hard and fast enough, it would travel up until it reached above 100 kilometers. And then it would just fall straight back down again. And that would be a suborbital flight. It would have gone to space, but it wouldn't have gone into orbit. To go into orbit, it's not enough to go up, You have to be going around as well. So the process of getting into orbit requires you to take off, and then be traveling kind of parallel to the Earth's surface at the appropriate velocity. So if you wanted to go into an orbit with an altitude of 222 kilometers above the Earth, you need to be traveling at a velocity of 7.77 kilometers a second. Chosen because you have 222 and 777. It's easy to remember. So suborbital spacecraft are much easier to build than orbital one, because they don't have to go so fast to go up, and when they're coming back down again, they're not traveling so fast, so they're not heating up in the Earth's atmosphere. So both the propulsion and the thermal control is much easier. So there are suborbital spacecraft and there are orbital spacecraft, and they tend to be very, very different from each other. You can still have business opportunities in each of them, but you build your craft accordingly. So, for instance, here we have suborbital, and here is the Earth. Here is 10 miles, 16 kilometers up. Here's airplanes. Here's 80 kilometers. This is 100 kilometers. The von Karman line, that's space. So a suborbital space vehicle tends to go up and then back down again in some way. While up here, space shuttles, space stations are orbiting way overhead. So the first big suborbital opportunity is probably space tourism. If you go in a suborbital spacecraft, you get to go up very high. You can look out the window. You see the curvature of the Earth. You see space. You see the stars. If it's a parabolic trajectory, you get to float around for a few minutes at the top in 0 G, and then you come back down again. You know, this is the sort of tourist trip that, you know, various companies are selling tickets for at the moment, but have yet to deliver. You can also do research up there. I mean, there's interesting microgravity science that you can do. You can have what's called a sounding rocket, which is just effectively a rocket that you fire up and it travels up, and then comes down. And while it's traveling over the top, it's in microgravity, and you can do various experiments there. You can, once you've got outside the atmosphere, you can have various astronomy payloads, you know, other sorts of payloads, upper atmospheric science, technical demonstrations of equipment, as long as they can be done quickly, because these suborbital flights, you know, tend to last half an hour to an hour. Okay, they go up and they come back down. They could also potentially be used for point-to-point. You know, I have a package here. I want to get it to New York quickly. You know, Concorde doesn't fly anymore. You know, where's my Amazon rocket? You know, you may laugh. Where's my Amazon rocket? Can I get it over to the other side of the Atlantic for a fee, you know, in a couple of hours? And you could, in principle, do that with a suborbital rocket. But it's a little more demanding, but it's not impossible. Or you've got orbital opportunities, things orbiting the Earth. And these two sets of initials are LEO, which stands for low Earth orbit. So that's basically anything that's orbiting the Earth up to about 1,000 kilometers, all the way out to geostationary orbit, which is GEO, where the big communication satellites are, and that's, you know, tens of thousands of kilometers out. And then there's areas in between. So at the moment, you'll find in LEO, you'll find space stations, you will find you know, remote sensing satellites. In medium Earth orbits, you'll find navigation satellites, and then out out there over the equator in geostationary orbit, you'll find all the big communication satellites. So they're used a lot at the moment, and this is collectively called Earth applications, because these are providing services for people on Earth. And this is where money is currently made, but there's more potential for making money in other ways. Obviously, there's the capability for research, and you know, over the last 6 months, we watched Tim on the International Space Station perform and take part in various experiments. There is also the possibility of space tourism to orbit. You could be an orbital space tourist instead of a suborbital one on a trip that lasts a bit longer. And then once you can do things in space, you can launch satellites there. These are a couple of small sats that have been deployed from the International Space Station just previously. In principle, although most satellites are not designed to be serviced at the moment, they put up there, and then when they run out, they are deorbited or put into a graveyard. You could service satellites, you could refuel them. The only thing we've really done this to very noticeably is the Hubble Space Telescope, where at various times the Space Shuttle rendezvoused with it and corrected the mistake in the optics, at various times replaced the solar arrays, and so on. So you could make all your satellites serviceable. You could have in-orbit fuel depots so that you could refuel spacecraft in space. And then lastly, of course, the typical thing with humans, anywhere they go, they make a mess. So over the last 50 years, we've been filling space up with debris. It's now getting to be a bit of a problem, frankly. And so there are people looking at whether there are commercial opportunities to actually clean space in various ways. It's a slightly tricky thing, because either somebody has to pay you to go and do it. How do you do that? Maybe you tax everybody who launches something into space, but then all the developing countries go, well, you know, it was Russia and America, and maybe you Europeans, you made the mess. Shouldn't you clear it up? I'm India. Why should I pay to clear up the mess that you made? Which is an ongoing, I've simplified the debate a little, but that's an ongoing discussion. But you know, there are quite a lot of people looking at potential commercial opportunities for debris removal. And then lastly, we get out into deep space. That should say beyond GEO. And then there's a very wide range of science and technology you can do. Obviously, if you want to send humans to the moon, if you want to send humans to Mars, you've got to keep them healthy, you have to keep them sane. So there's a lot of preliminary research you can do then. Extraterrestrial resource utilization, you know, moon asteroid mining, generate energy using the sun's rays. There are all sorts of potential ideas. You can make things in space. This is the first 3D printed tool in space that was printed on the International Space Station from a plan sent up from the ground. Or you can get to these bigger ideas where you start to grab asteroids and process them, or ultimately sort of establish human beings in space on other bodies. Or you could do even more tourism. You could do a tourist trip to the moon, maybe, if you're rich enough, or beyond. So these are all conceptually possible, though of course requiring different amounts of financial input. So let's look at some new space companies. There's some logos of various new space companies. Depending on how much you follow space, you may recognize some of those, you may not, but I'm going to talk about each of these companies and what they're doing as we go through. The first one, and probably the most famous one, is Virgin Galactic. Founded by Sir Richard Branson in 2004, so more than a decade ago now, designed to take tourists to low Earth orbit, which it hasn't done so far. I think it's fair to say that it's turned out to be a little bit more technically demanding than maybe they thought to scale up from Spaceship One, but still, according to them, intending to do it. They offer seats for £100,000 plus. For that you get, if I understand correctly, a 2-week package, but not 2 weeks in space. That's kind of 2 weeks kind of leading up to a short trip into space. But they have a lot of people who've put the money down. I have several friends who are obviously far wealthier than I am who have bought tickets. Admittedly, I think they've cashed in their pension. I suppose if I was to cash in my pension, I could do that. I'm not going to. I'd like to go to space, but not at that price. So here you have an aircraft, and underneath it carries a spacecraft. The aircraft flies up into space, drops the spacecraft. The rocket engine fires, and then it becomes a suborbital flight. The engine takes it up over to space. The people inside float around for a bit, and then you come back down again. They're also now, while the human spaceflight side, I think it's fair to say, has been more difficult, they're now starting to look at the idea of launching small payloads with a rocket launched, just a payload-carrying rocket launched from the spacecraft. Interestingly enough, they did start looking at this probably about 8 to 10 years ago, and then they decided they were going to stop looking at it and concentrate on the human side, and now they're back looking at payload delivery as well. This is Spaceport America in New Mexico. The nearest town is called Truth and Consequences, which I think has a sort of charming sort of kind of American name. There's a certain amount of contention, I think, going on. There was a certain amount of sort of favourable, tax laws passed to enable Virgin Galactic to set up there. There was a certain amount of investment from Truth and Consequences and the local governments in the area, and they feel, well, at least some of the people there feel that they haven't seen the return either in the amount or by the time that they were expecting, and so I gather things can occasionally be a little tense there. Interestingly enough, though, since in the UK we've started to talk about spaceports, although I was a little bit disappointed when I discovered in the last budget speech that instead of choosing a spaceport, the UK government had decided to dodge the issue and go, well, anyone can have one if they want. If you want to find the money, you can have a spaceport. Later, yeah, we'll get back to one. But it's nice to think we could, at least in principle, one day see Virgin Galactic, operating from Newquay or somewhere like that. At the same time, there's other people, newer projects. This is the sort of dark horse, painted a tasteful black. This is Swiss Space Systems, who suddenly kind of popped out of nowhere a few years ago, and they're working very hard on this. Oh, I've left an M out there, $10 for a launch to 250 kilograms. I can only dream of that. That would be, so $10 million for a launch to 250 kilometers, I think I should say. So they are designing this rocket plane here, which will be launched on the back of a A300 Airbus. Here you can see their, one of their posters, and this lovely Space for All. I think if you look carefully on here, somewhere, I think, was it this one? There was a Breitling watch logo, because they've done a deal with Breitling. because again, they're trying to hit two markets at the same time. Space tourists who want to do suborbital space flights, microgravity science maybe on the same vehicle, and then ultimately deployment of satellites as well. But when you buy a ticket with Swiss Space System, when you get to fly, you get a Breitling Explorer watch or something like that. They've also done some interesting kind of social looking at their different customers. Because I saw some plans of the vehicle, and kind of like down the front end of the vehicle for the microgravity flights that you could do just in the Airbus, there was the kind of party zone. So this is where all your gaggles of young people would go to hang out and have a good time. And then there was a sort of more quiet, reserved zone for the slightly richer, middle class people who want a little bit more peace to tumble head over heels and throw up. And so, they'd obviously done their market segmentation survey there to find out who wanted to. They believe there's a market at least for experiments. Whether it for if you were to start charging people by how much they weigh, that would be kind of I think interesting. Also, I'm surprised Ryanair hasn't done that yet. Time will tell. I mean, for a science experiment, $40,000 for a kilo, to have it flown is pretty cheap. But there are other approaches. Zero to Infinity have a balloon-based approach. This is a Spanish company. I suppose if I'm plugging ISU, I should also mention that we have ISU people working in Virgin Galactic. The Chief Technical Officer of S3 is an ISU Masters alum, and we also have ISU people working there in the legal side of this company. ISU gets everywhere. They're even sitting at the back now watching you. So what they want to do is they build these big balloons, and they want to use them for two potential things. One is to launch payloads. There's a technique or an idea called a rockoon, not to be confused with a raccoon, which is a small furry animal. A rockoon is where you effectively dangle a rocket under a balloon. You get the balloon to go to high altitude, and then you fire the rocket, thereby saving the first stage. And so they have a plan for that using what they call Blue Star. They've obviously done their marketing as well, because it's called Balloon, and then Blue Star. And so Balloon then carries these pods up underneath to about 30 kilometers. They call it near space, and it's one of these arguments. Every time I see one of these stories that says, so-and-so has flown their payload to space on a high altitude balloon, I go, no, that wasn't space, it was only a third of the way there, only got to 30 kilometers. But it's still, the point is, if you go up to 30 kilometers, you can see the dark of the sky, you can see the curve of the Earth, okay? You can get the looking down on the Earth experience, okay, without all the complexity of having to go up in a rocket. And so I've spoken to them about this, and they think that there will be a market for this, that people will pay, not as much, obviously, for a flight to 100 kilometers, but there will be a market for people going up very, very high and looking down over the Earth. And so they're developing two products. And they're not the only people. I could have also covered the American company, whose name I've temporarily forgotten now. Tabor McCallum's outfit. I should know, because we had an intern there last year. Worldview. Thank you, Manny. Yeah, Worldview. So Worldview are doing something similar, but in the USA. And I've also heard of similar projects being discussed in other parts of the world as well. So I think over the next 5 to 10 years, you'll probably see a number of these very, very high altitude balloon companies carrying people. Maybe they'll launch payloads into space, maybe not. But this falls under the remit of new space. And then, of course, the other one that everyone's heard of is SpaceX. If we're going from balloons to big rockets. Now, I think most people know that sort of SpaceX was founded by Elon Musk, who was one of the founders of PayPal. This is the start of a kind of common thread we'll see in some of these new space endeavors, where people who've made a lot of money out of what I would call the internet then decide to spend some of that money on doing cool space stuff. And basically, Elon has this as one of his hobbies, building rockets. And he decided that he wanted to launch things into space. He wanted to go into space. He's on record as having said he wants to retire on Mars. Is it always like this here? He didn't say how long he hopes his retirement to be, but we will see. And he has been consistently working with his team on building rockets, and he's followed quite a sensible business plan. He started off by first of all designing a rocket completely from scratch, so it had no previous heritage. It wasn't a spin-off from anything that had existed before, because one of the problems with some of the heritage launch systems is they were originally designed for government work, and in engineering terms, this is really designed for performance. In other words, I don't care how much it costs, as long as it does what it does very, very well. It doesn't have to be cheap to build. It doesn't have to be cheap to operate, because the government is paying for it. It just has to drop the bomb very accurately over there. And then we turn that later on into a launch. Again, I'm massively simplifying, but that's part of the story. Whereas what they did, they set off with the specific intent of designing a rocket from scratch to be cheap to build, and more importantly, cheap to operate, cheap to maintain, with the capability in due course of parts of it being reusable. So they were looking at the total lifetime operation cost and saying, how can we lower the cost to make this commercially attractive? And that's where they have done very well. In particular, they started off by building a small rocket, the Falcon 1, and it had some teething troubles, but eventually it started working. They launched some payloads. They made some money. So they could take that money and then use it for the next stage. And they've done this kind of build a little, launch a little, make a little bit of money, reinvest. And so that gives you a nice, sound business model, which then attracts other investors in. This has to be compared at the other extreme to, say, Aerospace Planes. Now, in the UK, some of you may have heard of Reaction Engine's Skylon design. I am a big fan of Skylon. I've known Alan Bond for several decades, and he's a damn fine engineer. The problem with Aerospace Planes is before the first one flies, you need that $40 billion up front. Okay, all of it, because it's a high-tech, very complicated vehicle. If it comes to fruition, it's going to be awesome. And that, in my heart of hearts, that's how I think we should be getting to space. In aerospace planes, not in rockets. Rockets are okay, and you can do things to make them cheaper, but aerospace planes is what I think we should be doing, where I had hoped we would be by now from when I was 10 years old. But you do need significant upfront investment. And if a government's not going to put that money in, then you've got to find private investors. Whereas something like SpaceX, you can develop a bit at a time, incrementally, and so you've got a more commercially attractive business plan. So they built the rockets, they built the Dragon capsule here, which at the moment is being used to ferry payloads to and from the International Space Station. It's true to say that SpaceX is partially commercially success because it's got a $1.6 billion contract from NASA to deliver the payloads. But then so have some of their competitors. NASA's let a couple of contracts. Orbital Sciences have also got a similar contract using their Antares vehicle and their Cygnus capsule. And in due course, this is going to start carrying astronauts to the space station and into orbit. But even more so, Elon is apparently very, very focused on going to Mars. And for some years, there have been discussions with the NASA Ames Research Center and the then head, Pete Warden, about a mission concept called Red Dragon. And here you can see one of the early stills. This is a Dragon capsule which can land on rocket engines. It was designed like that from scratch. That one? Well, this is an artist's impression. I'm not responsible for Elon's artists. I don't know if that's right or not. It might depend on the Mars pressure. But the point is, this showed a Dragon capsule landing on Mars. As of a couple of weeks ago, there is now a NASA SpaceX plan to launch a mission using a Dragon capsule to Mars as early as 2018. I always say as early as, which usually means it'll probably be some years later on, but that's the current target, is 2018. So we're seeing a kind of NASA SpaceX mission. And then there's a big space conference every year called the International Astronautical Congress. It usually happens in September, and some of us will be there. And one of the interesting attractions this year is that Elon has made it known that he's going to make his big announcement about how he plans for humans to colonize Mars at this conference. So everybody in the space world is kind of waiting till September to find out. And he's been kind of dribbling out little bits of information in the meantime because he wants to take serious numbers of people to Mars. So we wait and see on that one. But you certainly can't fault Elon on dreaming big. You know, he wants the ships. Well, it'd be thousands. There are allegedly rocket designs for what's called the colonial transport, designed to take 200 people at a time. We wait and see about that. But that's his plan. And as I say, if nothing else, it stimulates debate and conversation. Other internet, I think some of you have heard of this company, Amazon. Jeff Bezos has had his own space company for many years called Blue Origin. And while SpaceX has been out there very publicly doing stuff, the question that people usually ask about Blue Origin is, does anybody know what they're doing? Because they've been, up until recently, extremely secretive. You would occasionally see an advert for new staff. You would occasionally see one or two pictures or a video of them testing their capsule. And then, I don't know, a year ago or something, that started to change, and we started to, first of all, see pictures of this capsule being kind of blasted across the sky on rockets to test the escape system. And then we treated to pictures of the rocket itself actually taking off. And Jeff, whenever he sends out his emails, he finishes up with this line, "Gradatim ferociter," step by step. Okay, and so it's very much a kind of incremental development. It's not intended as an orbital vehicle. It's intended as a suborbital vehicle. It's flown up to 100 kilometers. It did its fourth launch and recovery without any problems last weekend. You can see the capsule on the top. So what happens is the rocket goes up, the capsule comes off, does whatever it's going to do, and then the rocket comes back down without the capsule and lands back on the pad. Just like they're meant to do in all those 1950s science fiction films. Go up and then come back down again. And they did a test last weekend with the capsule. The capsule comes back down on parachutes. It's got 3 parachutes, and they deliberately sabotaged one of the parachutes to make sure that it could come down safely on 2, and it did. So it's what we call a VTVL, vertical takeoff, vertical landing. According to them now, they're saying they're going to do the first human flights in 2017. And commercial operations starting in 2018, space tourism, and also microgravity science and payloads as well. There's going to be a big surge, I think, in microgravity science opportunities, both here and in Europe, because there's a bunch of European companies working in this broad area as well. Which brings us on to NanoRacks. I put the NanoRacks slide right after the Blue Origin slide because NanoRacks now have a contract with Blue Origin there as well. Now, NanoRacks is quite an old company, but it's almost unique in the field, because what NanoRacks did was said, the space station has a certain amount of space on it, and it would be really good to fly payloads there. But it's very difficult. If you want to fly a payload to the space station, typically if you're a scientist, you have to go through peer review, it has to be selected, it costs all the money. So what NanoRacks did was they executed a specific agreement with NASA, which allows them to be the interface. So I can literally go to NanoRacks and say, here is $50,000, fly my payload to the space station. They deal with the interfaces with NASA. I don't have to worry about the licensing of the payload with my country. It counts as a US payload no matter where it comes from. And so you can commercially fly payloads. And all sorts of people have flown payloads. We've got one hopefully going up there December, January time. And they're all built on this form factor. They all get slotted into a box by an astronaut on the space station. So they go up, say, in a Dragon capsule or a Soyuz. The astronaut offloads them, slides them into the rack on the space station, press the button, and walks away. Very little astronaut time involved, because astronaut time is expensive. They also launch CubeSats. So you can see this is an arm on the space station, and you can see the kind of NanoRack symbol, and this is a couple of CubeSats being deployed. Which brings us on to CubeSats. CubeSats, in their essence, started off as small 10 by 10 by 10 cubes, 1 kilogram. designed to be used for student purposes, but they've actually stimulated all sorts of developments. And this is a company called Planet Labs, which was founded in 2010 in the US. Which, you know, I have to do the obligatory boast. 2 out of the 3 people there are ISU alumni. And they literally started off building these satellites in their garage because they've taken on board a Silicon Valley approach. You know, in the past, space hardware, you built it really carefully, you tested the hell out of it, because if it went up there and didn't work, somebody had lost a lot of money. They're working on the let's send lots of satellites up. Doesn't matter if 1 or 2 of them don't work because the rest of them do. We can have a very good cycle time. The question is now, you know, not is it perfect, but is it good enough? This was a slightly transformational moment for me when I met an American tech investor who said, oh, yeah, I don't care if it's perfect. I just want to know, is it good enough for me to make money so I can then invest in the next cycle? And so this is another aspect of new space. It's very heavily influenced by sort of Silicon Valley IT software, hardware development processes, where the cycle time is much quicker. Tech development can happen much, much more quickly. A typical kind of low Earth orbit satellite before would last 15 years, you know, and then you'd launch another one. If we look at another company, okay, which I also have to boast about because this was founded by 4 of my master's students almost exactly 4 years ago, while they're on their internships. No pressure, you guys. And it's now worth $65 million. And again, it's the same process, okay? Small satellites, they're planning to launch all these CubeSats. They're going to have a constellation of about 50 in due course and replace them every 2 years. And so they're effectively cheap, disposable satellites. They don't stay up there very long. You can't control them perfectly, but it doesn't matter because you've got a lot of them and there's always more on the way. So it's a completely different approach to how you do space. This is a little bit old school, though. I mentioned orbital space tourism, and we've had space tourists. In fact, this is where space tourism really started. This guy here, Dennis Tito. And since 2001, this company has done deals with the Russians to send rich people to the International Space Station. You have to be rich because it costs about $25 million a pop. So if anyone here has $25 million that they don't want, see me afterwards. Now you note here that they've launched 7 clients on 8 successful missions. Because Charles Simonyi, okay, he went twice. 2629. When you're one of the 3 founders of Microsoft, you can afford this sort of stuff. So he deployed 25 million twice. It was apparently going to go a 3rd time, but and one of the other founders, Paul Allen, has a big space launch project at the moment that he's working on, which is effectively a very large winged aircraft, which will carry a rocket up for launching payloads as well, Stratoliner. But I didn't put that slide in because there wasn't time. And it also shows you can be a clown and be very rich. This is Guy Laliberté, the founder of what's that Canadian circus? Cirque du Soleil, thank you very much. Cirque du Soleil, and so on the basis of that, he's rich enough to fly to space. Bigelow Aerospace, okay. Robert Bigelow had a hotel chain, okay. Then he decided he wanted hotels in space, so he bought some intellectual property from an old NASA project, and is developing these inflatable modules. You may have seen in the news recently the beam module. I'm a bit behind, so I'll mention Moon Express. Okay, they're currently trying to get permission to go to the moon from the US government as a private mission as part of something called the Google Lunar X Prize, and there's lots of other companies also trying to fly, Astrobotic being the probably most notable other one. Deep Space Industries, asteroid mining. I know you wanted to hear about asteroid mining. Here we are at the last slide, but I've just about run out. But this is one of 2 asteroid mining companies. The most interesting thing to note here, I think, in the world of asteroid mining is that the Luxembourg government has just tried to do for asteroid mining what it did with satellite telecommunications, which is to put in a large chunk of government money now in the hope of it paying back massively in the future. So Deep Space Industries and Planetary Resources, which are the 2 companies, are both being in partnership with the Luxembourg government now. They're not going straight for these big spacecraft yet. They're all working on smaller spacecraft and developing their business model to work out how to do it. But if they work it out, then in about 10 or 20 years, we'll have spacecraft going around in space, grabbing bits of asteroid, processing water, making things to support other space activities. Last slide, just to show you that it's not just me. This is some of the money, okay, that is going into it. You can see 200 million to 2 billion categories there. So Planet Labs, SpaceX, Blue Origin, 20 to 200 million. Some other ones, Moon Express that we saw just there, Spire. Okay, 2 million to 20 million. You know, some of the other ones, Reaction Engines. Okay, that's Skylon. So there are venture capitalists out there with money to invest in these, you know, in these sort of projects, as long as you can convince them. That's it for now. Sorry to overrun a bit. But I think we take a break now, and then if there's any questions, I'll answer them right or later. Thank you very much.